Hi, this is Betsy, and we're going to talk a little bit now about simplifying fractions. A big part of it is recognizing when a fraction is already in its simplest form. That is, when it's in, sometimes it's called the reduced form or reduced to lowest terms. So, a big part of that is knowing as you look at the fraction, the numerator in the top and the denominator in the bottom, is there a number that goes into both the top and the bottom that is a number other than 1, because 1 goes into everything and that's not really going to help. So what I want to talk about right now is recognizing pretty quickly whether you can divide something in the bottom. So when I say goes into, we really mean division. And so the key would be to kind of look really quickly at the numerator in the top and the denominator in the bottom and think to yourself, does 2 go in there? Does 3 maybe go in there? How about 5? So you'd start to think of in terms of the prime numbers that might go in and help you reduce that fraction to simplest terms. So there's a couple of quick ability rules that are really worth keeping in mind. Even if you've got a calculator right there, if you remember these rules, it can go even faster and can kind of help you think about even how you might use your calculator to help you reduce things. First of all, we know that 2 goes into a number if the last digit of the number is even. Okay, so if the last digit is a 0 or a 2 or a 4 or a 6 or an 8, you know that 2 is going to go into that bigger number. The divisibility rule for 3 is a little bit trickier. That's this one right here. Okay, and we can think about why this is true, but that's for another day. But the way the rule works is if you take all of the digits of the number and you add up all the digits, does 3 go into the sum of all those digits? And if it does, then it goes into the original number. 3, the original number is divisible by 3. So that's a little tricky, but once you get the hang of it, it works really well and quickly, and you can figure out whether it's worth dividing 3 in to help simplify that fraction. And then the other one I want to talk about is also a pretty easy one, and that is that you know that a number is divisible by 5 if the last digit in the number, however big the number is, but if the last digit in the number is 0 or 5, you know that 5 would go in evenly. So those are some things. There's a divisibility rule for 7, and I think there's one for 11 as well. But those are maybe not quite worth remembering. They're a little more complicated. And at that point, if you're wondering if 7 goes into something, or 11 or 13, you might be well to just divide it out by hand and see, or even use a calculator to see if that would help. So let's see how some of these simple ones, these rules about 2, 3, and 5, how that works. So for example, here's a fraction, 84 over 66. It's an improper fraction, and you can think about why. That would be because 84, the numerator, is bigger than 66. So that's one thing just to refresh your memory about improper fractions. So first we might say to ourselves, well, does 2 go into the top and the bottom? Well, it would, because 84 ends in a 4, and that's even, and 66 ends in a 6, and that's even. So we know for sure that 2 goes into the top and the bottom. So that might be the first place to start, is 84 divided by 2. And then we're going to try to do 66 divided by 2 to start to reduce that fraction. Now the book talks about reducing fractions in a little bit different way. I'm going to talk about that in a second. But this is how I find myself usually doing it. So we're allowed to do this. It's because we're doing the division by 2. We're doing it to both the top and the bottom of the fraction, so that's okay. So we're not changing the value of the fraction. It's still representing the same amount in a way. So 84 divided by 2, you might do that in your head or using a calculator, would be 42 divided by 66 divided by 2 is 33. So would 2 go into top and bottom again? Well, no, because 33, the last digit there is odd, so 2 wouldn't go in. So 2 is not going to help us anymore on that. So we might think to ourselves, does 3 go in? Well, the divisibility rule for 3 says, let's see, if you add together the digits, 4 plus 2, that's 6. Does 3 go into 6? It does. So that means that 3 does go into 42 evenly. Does 3 go into 33? It looks pretty promising, but let's just use the test. 3 plus 3 is 6. When you add up those digits, you get 6. Does 3 go into 6? Yep, it does. So that means that 3 should go into 33 evenly as well. So let's try to divide top and bottom by 3 in this aim to simplify. Okay, so 42 divided by 3 would give us 14, and 33 divided by 3 would give us 11. So then the question is, can we go any further, just, without making it into a mixed number, but can we simplify that improper fraction anymore? Well, let's see. 2 doesn't go into both of the top and bottom. 3 doesn't. 5 doesn't go into top and bottom because we don't have things that end in a 5 or a 0 digit. 7 goes into 14, but it doesn't go into 11. 11 obviously goes into 11, but it doesn't go into 14, so I think we're done. So, simplified improper fraction there would be 14/11. Now, just real quickly to match that up with the kind of the more official way, perhaps, that the book. So if we match that up a little bit, that sort of unofficial way to simplify fractions with what the book says, the book tells you to look at the numerator and the denominator and to try to factor those out as far as you can down to prime numbers. And that is one way to do it, and it's not a bad way to do it, but to be honest with you, it's not the way I usually think about it. So I invite you to use the way that you think is most helpful. So if you look at 84, 84 is 2 times 3 times 7. And one thing to notice about all of those are they are prime numbers. They can't be broken down into factors any further. And same thing down here in the denominator, 66 is 2 times 3 times 11, and 2 and 3 and 11 too are prime numbers, so you can't break those down any further. And so it's the prime numbers that really get you to the most simplified version of that factor. And so at this point, what happens is that we can start to, in a sense, cancel things in the fraction. And 2 divided by 2 is really 1. So 1 times anything doesn't change anything. So you can cancel the 2's. 2 over 3 we couldn't cancel, but we can cancel this 3 and this 3. 3 divided by 3 is just 1, and 1 multiplied by anything doesn't change it. So if we do that, then, and there's nothing else that cancel. 2 and 11, there's nothing to cancel there, and 7 and 11, we can't cancel anything there. So if you multiply out what's left, we get the same reduced fraction, but completely simplified as an improper fraction, 14/11. So those are 2 ways to think about simplifying fractions. I think no matter what you do, those basic divisibility rules for 2, 3, and 5 can be a great help when you're looking to reduce fractions.